Hello, good afternoon. Am I audible, ma'am?
Yes.
Hi. Okay. Good afternoon. Am I audible to you?
लिंक की तरह म्यूट करते हैं तो फिर शेयर करते हैं क्यों नहीं आ रहा स्टूडेंट
ज्वाइन नहीं किया। स्टूडेंट ज्वाइन नहीं किए अभी तक।
के 10 मिनट में
सर सिर्फ वो क्लिक कर करके नहीं रौनक
होने देखना इतना क्या चलेगा
एक भी नहीं आया अभी बस इसी का यहाँ दिख रहा है।
बच्चे आ रहे हैं ना
अरे आई नहीं।
बच्चे भी ज्वाइन करो आप ज्वाइन करो स्टूडियो स्कूल बता स्टूडियो स्कूल क्यों बता होना चाहिए ना आपको समझ मेरे जो कहाँ आपका ये
Hello, good afternoon. Are you able to? Hello. Are you able to get me? Are you getting my voice? बच्चे ज्वाइन नहीं किए। नहीं वो इसमें बता ना ब्राउचर में से बता।
ब्राउचर्स में से बता
सर मेरा सब ऑन है वो किसी के लिए
बच्चे की नहीं आते देश को भेजे बच्चे आए ना सर ये क्या है बच्चे
बच्चे आए लेकिन यहाँ दिख रहा है ना व्यूअर्स नहीं है ना। देखो फिर मैं हूँ
उसको बोलता
जुलत को जुलत को लाओ।
अरे जुलत आने
चौदह चार
सर हमारे बच्चे शोक ही नहीं कर रहे हैं यहाँ पे नीचे दिख रहे हैं वो सब आने कर बच्चे लाइव भी नहीं बता रहे हैं बड़े नहीं आ रहे हैं पर लाइव में नहीं आ रहे ना आप खोल के देखना
डिवाइस नॉट कनेक्टेड बोल रहे हैं।
नहीं आ होम में दिखेंगे इसके लिए ये
बच्चे आए
ऊपर हाँ उसके ऊपर
लेकिन व्यूअर्स में नहीं आ रही, बोला व्यूअर्स में नहीं आ रही,
व्यूअर्स में क्यों नहीं आ रही? व्यूअर्स
जो आखिरी थी उसमें नहीं आ रही।
आखिर में थी उसमें क्यों नहीं आ रही? पहले लिंक डिलीट मार देता।
नहीं मतलब
नहीं नहीं पहले डिलीट मारना है ना, पूरी डिलीट मारना है।
Smita ma'am, am I audible to you?
Yes, sir.
Okay. So can we proceed?
Yes, sir. Is this PPT visible? Sir, the presentation is shared, but it's not seen on the screen. Okay, so we'll start. What is nanotechnology? Nanometer is a billionth of meter, that is about 1 by 80,000 of the diameter of human or 10 times human hair, or 10 times the diameter of hydrogen atom. So a nanometer is very, very small. It is of the size of 1 by 80,000 of the diameter of the human hair. So if we blow a tennis ball to the size of the earth, the atom of the tennis ball will be about size of the grapes. So if we measure the width of 10 atoms placed side by side by size, we would have a nanometer. So all the technology which deals with nanometer or the scale of nanometer is called as nanotechnology. So we'll see what is nanotechnology in detail. So nanotechnology is a manipulation of matter on the subatomic, molecular or supramolecular scale. So here we are trying to manipulate the matter or any you can say body by going at the submolecular level or at the atomic level. A more generalized description of nanotechnology is that it was given by National Nanotechnology Initiative, which defines nanotechnology as manipulation of matter which at least one dimension size from 1 to 100 nanometers. So out of the three dimensions, at least if the one of the dimensions of the matter is in 1 to 100 nanometer scale, then we call, or that particular solid can be studied under nanotechnology. So nanotechnology is defined by size, which is naturally very broad, including the fields of science as diverse as surface science, organic chemistry, molecular biology, semiconductor physics, microfabrication, molecular engineering. All these are the fields in which nanotechnology is being studied and being utilized, or the applications of nanotechnology are broadly seen in so many of the fields, including chemistry, physics, at the molecular engineering and biology, and in the microfabrications in many industries. It was first, the term nanotechnology was first discussed, and it was basically talked about by the renowned physicist Richard Feynman in 1959. He was giving a lecture and he described the possibility of direct manipulation of atoms at the subatomic level, and he said that there is plenty of room at the bottom. This is a famous line which basically gave the description of nanotechnology or the introduction of nanotechnology to the world, and it was done by Richard Feynman. The term nanotechnology was first used by Norio Taniguchi in 1974, though it was not widely known at that time. So, as I've already told you, the first ever concept was presented in 1959 by the famous professor of physics, Dr. Richard P. Feynman. He was giving a lecture in which he said the famous line, "There is a plenty of room at the bottom." Invention of scanning tunneling microscope, which we call as STM, in 1981, and the discovery of fullerene, which is carbon 60, in 1985, led to the emergence of nanotechnology. And as I already told you, Norio Taniguchi in 1974 coined the term nanotechnology. Now, how small is nanoscale? I have already told you it is very, very small, about 1 by 80,000 of the diameter of human hair. And you can say that the DNA, which is approximately 2 nanometers. So basically, a nanoscale is very, very small. You can say DNA is at the nanoscale, which is at about 2 nanometer, and a human hair is approximately 10 to the power 5 nanometers. What is nanoscience and technology? Basically, you will find nanotechnology or nanoscience or the objects in the nanoscale in nature. Okay, the certain examples are given on the slide. You can see the head of the pin, these DNA, human hair, fly ash. All these are certain examples where you will find the particles in the nanoscale, that is ranging from 1 to 100 nanometer. Now, what is the difference between nanoscience and nanotechnology? Here we are going to discuss both. Basically, nanoscience is nothing but the study of small things which are in the nanometer scale from 1 to 100, seeing how it affects chemistry, biology, physics of the material, how it affects material science, how it affects engineering. So, basically, studying the material at the nanoscale, its impact, its applications, its uses, and how these nanomaterials are synthesized, how they are prepared, and what effect it will have in different fields of our day to day life. That basically comes under nanoscience. So, nanoscience is basically studying and understanding the applications of extremely small things that we come across in the other sciences as well as engineering. Nanotechnology, on the other hand, is creating many new materials and devices with vast range of applications, such in the case of medicine, electronics, biomaterials, and energy production. So, nanoscience basically talks about the study of the materials in the nano range, whereas nanotechnology talks about the creation of the nanomaterials or creation of the devices using nanomaterials, which can have varied applications in various different fields. So, what are nanomaterials? Nanomaterial fields include subfields which develop materials having unique properties arising from the nanoscale dimensions. So basically, when you take a material at the nanoscale, its properties are very unique. They are different from the properties of the material at the in the bulk form. So basically, studying all the properties, unique properties at the nanoscale is nothing but the study of nanomaterials. So interference and colloidal science have given rise to many materials which may be useful in nanotechnology, such as carbon nanotubes are very, very important, and other fullerenes and various nanoparticles and nanorods. Nanoscale materials can also be used for bulk applications. There can be various bulk applications of nanomaterials as well. Now, if you compare the properties of the materials at the nanoscale, ranging from 1 to 100 nanometer scale, with the bulk material, so you will find that there is a lot of difference in the properties of nanomaterials, which are in the range of 1 to, let's say, 100 nanometers, than the bulk materials. Because bulk materials have the properties which we are aware of, but nanoscale will give you, or nanomaterials will give you unique properties, which can again be used in various applications. Physical and chemical characteristics of the nanomaterials. Now, if you compare the physical and chemical characteristics of a nanomaterial with the bulk material, then you will find that nanomaterials will exhibit some unique physical properties, which include some electrical, catalytical, magnetic, mechanical, thermal, or imaging features that make the nanomaterials a relevant topic in medical, pharmaceutical, and different engineering sectors. For example, color. There are few examples where materials will show you a different color when they are converted to nanoparticles. Gold is the biggest example. We will discuss it further in the subsequent slides. Gold nanoparticles melt at a much lower temperatures, that is about 300 degrees Celsius for 2.5 nanometer size. Then the gold slabs, which are melted at 1064 degrees Celsius. Absorption of solar radiation in photovoltaic cells is much higher in the nanoparticles than it is in thin films of continuous sheets of bulk material. So this is a different property. Since the particles are smaller, they absorb greater amount of solar radiation. Melting points basically drastically fall when the particle size of the material approaches a nanoscale. So, melting points of bulk materials are far different from the materials at the nanoscale range. The melting point drops when the material is synthesized at the nanoscale. The phenomenon relates to the melting point depression, is very prominent in nanoscale materials, which melt at temperatures hundreds of degrees lower than the bulk materials. Mechanical strength. All the nanomaterials possess very high mechanical strength as compared to their conventional counterparts in the bulk. The mechanical strength to the nanomaterials may be 1 or 2 times higher in magnitude than that of a single crystal in the bulk form. This we have already seen, and I already gave you the example of gold. So this also comes under the optical properties, which are different in the nanoscale, whereas the optical properties will be completely different when you will consider the material, its counterpart in the bulk form. So bulk gold appears yellow in color. We all know that there is a ring of gold shown at the slide. So basically, if you consider a bulk gold material, it is obviously yellow in very characteristic yellow in color. Sorry, and if you take gold at the nano scale, you will see that the color changes from yellow to red. So 12 nanometer gold particle, if you look at it, is red in color, not yellow. So the particles are so small that electrons are not free to move about as they move about in the bulk gold. Because of this movement restriction, the particles react differently to light, and therefore the color changes. Color appears different. So we can say that the gold changes its color when it is decreased from, or the size is decreased from bulk to nano. So at 12 nanometer it is red. At if you reduce the size further or increase the size, color may vary from red to any other. So, as we were discussing the physical properties like optical properties, electrical properties, catalytical properties, many properties are different in the bulk form than in the nano size. One of the most fascinating and useful aspects of nanomaterials are their optical properties. The optical properties are very unique of the nanomaterials. They depend upon features like size, shape, surface characteristics, and other variables, including doping and interaction with surrounding environment or the nanostructures. So applications obviously will also be different because nanomaterials, they show different reactions to the optical properties. Electrical properties, conductivity of bulk or large materials, they do not depend upon dimensions like diameter or area of cross section. However, it is found that in the case of carbon nanotubes, conductivity changes with change in area of cross section. So, conductivity is totally different when taken at the nanoscale, but in the bulk, you can see that there is no relation upon, there is no dependence upon dimensions like diameter or area of cross section, whereas this creates a huge impact when it is in the nanoscale. The cross section, area of cross section, diameters, they change the conductivity in the nanoscale. It is also observed that conductivity changes when some shear force or a twist is given to the nanotube. So, conductivity, basically, resistivity, conductivity, these are the electrical properties which are observed to change at the nanoscale level, just like optical properties change when they are taken to the nanoscale, nano size scale. So, just to give you an example, carbon nanotubes can act as conductor or semiconductor, but we all know that carbon is a good conductor in the bulk form. Mechanical properties, they have they have very high mechanical strength when taken at the bulk level, or sorry, when taken at the nanoscale. Mechanical properties of nanoparticles compared to the bulk metals have a lot of strength. Um, you can say that the experimental studies on mechanical properties of bulk nanometers are generally impaired by major experimental problems in producing specimens with exactly defined grain size and porosities. Mechanical properties of nanomaterials are only of quite basic interest because it is problematic to produce macroscopic bodies with high density and a grain size in the range of 100 nanometers. But it is in general observed that the mechanical strength increases when taken at the nanoscale. Magnetic properties are also influenced when, and they are also unique when taken at the nanoscale. Um, Bulk gold and platinum are non-magnetic in nature, we all know that, but at the nano size they are magnetic. Ferromagnetism in platinum arises from the structural changes associated with size effects. So when you take platinum at the nano scale, it introduces the magnetic properties because of these structural changes happening, and also because of the size being reduced. Surface atoms are not only different to bulk atoms, but they can also be modified by interaction with other chemical species, that is by capping the nanoparticles. Bulk gold has an extremely low density of states and becomes diamagnetic, as is also the case for bare gold nanoparticles. However, gold nanoparticles have become ferromagnetic when they are capped with appropriate molecules. The charge localized at the particle surface gives rise to ferromagnetic like behavior. So we know that the materials which are non-magnetic in the bulk form, they become magnetic at the nanoscale form. They achieve what we call as ferromagnetism or diamagnetism when taken at the nanoscale. So basically, to give you a conclusion about comparison of the properties of nanomaterials with the bulk materials, we can say that when nanomaterials are compared with bulk materials, certain advantages of the nanomaterials over the bulk materials we get. We what we get is a large surface area when you take the materials at the nanoscale range. So we get large surface to volume ratio and very high volume capacity, which can be used in information storage. So always remember, when you talk about nanomaterials at the nanoscale ranging from 1 to 100 nanometers, you will find that compared to the bulk materials, nanomaterials have very large surface to volume ratio, and they have very high volume capacity, very large surface area, because we are manipulating, as you know, the matter at the subatomic supermolecular level. So this increases the surface area, and that increase in the surface to volume ratio is advantageous for various applications and for the unique properties of the nanomaterials compared to the counterparts like bulk. Uh, if the nanomaterials are considered, they have high speed of information processing. They give you high speed of information processing, reduces power consumption when used for power consumption, high packing density. They are found with very high packing density, reduced number of imperfections. Nanoscale materials have very less imperfections at the nanoscale. Electronic devices prepared, like semiconductor devices usually prepared with nanomaterials, will be much smaller in size, much faster in capacities, and more sophisticated functions can be seen if you fabricate the nano sized electronic devices with nanomaterials. You will find that they have very small size compared to the bulk material being used. They are very fast compared to the bulk, and they are much more sophisticated and will give you variety of functions. And growth and catalytic chemical reactions, they occur at surfaces, and here the surface to volume ratio is very high, so hence nanomaterials are very highly reactive. So as far as chemistry is concerned, so chemical reactions get affected, and you can say that the catalytic behavior of nanomaterials is very highly reactive. How these materials are synthesized? So there are various approaches, basically two major approaches which are used for fabricating the nanomaterials. We know that nanomaterials, they deal with very fine structures. A nanometer is about a billionth of a meter, and this indeed allows us to think in both bottom up and top down approaches to synthesize and prepare the nanomaterials. So either we assemble atom by atom, putting atom by atom together, or that approach is called as bottom up approach, where we are preparing or synthesizing the nanomaterials by adding one atom by another. So assembling atoms together is the bottom up approach. Or if you have the bulk material, you disassemble, break, dissociate the bulk solids into finer pieces until they are constituted of only few atoms. So these are the two ways or two approaches by which you can process, synthesize and prepare the nanomaterials in the labs. So basically the first approach is the bottom up approach, wherein you will be uh, producing the nanomaterials by assembling atoms one by other. That means assembling atoms one by other together. And if you have a bulk solid and you are dissembling the bulk solid, breaking the bulk solid, dissociating the bulk solid into very fine pieces until you have only a few atoms, that approach is called as top down approach. So you can see that from the bulk, if you are breaking the bulk solid, then into smaller pieces and then smaller pieces, and finally when you have few atoms remaining, that approach is top down. Bottom up is adding atom by atom and assembling the nanomaterial where few atoms are there. Top down approach, there are various top down approaches, but I'll discuss only one, that is called as a ball mill method. And its advantages we are going to see. So ball mill or ball milling is one of the top down approaches where a bulk material is grinded to nanoscale. So a ball milling method, also called as mechanical crushing, is a type of grinder with the help of which bulk material is cut into the smaller pieces and finally extremely fine powder is obtained. We have a cylinder, a metallic cylinder, and it rotates about its horizontal axis. Now, this cylinder consists of small balls, usually made up of stainless steel or ceramic material. As you can see in this diagram, you have a metallic cylinder and it is rotating about its horizontal axis. And here in the cylinder, we have some steel balls, or you can say ceramic material balls, and these balls are put together inside the cylinder. And then the material that you want to like break and dissociate into the nano form, that material is also put in the cylinder along with the balls. When the cylinder rotates, a centrifugal force is produced, due to which the steel balls are carried to the height and then they fall with high kinetic energy on the material due to gravity. And due to this, the material gets grinded or it gets crushed. So the material crushes into very small pieces, and this process continues and material gets grinded, resulting into extremely fine powder having particles in the scale. So ball milling is a very common technique used for getting the fine nano-sized powder. Basically, this is a top-down approach where a bulk material is being grinded or crushed into very small particles, which are in the nanoscale. So here, this is a very easy method where you use a metallic cylinder, few stainless steel balls, and you rotate the cylinder about the horizontal axis with the material inside it. The material finally, because of the balls and the gravity due to centrifugal force, gets crushed into very small pieces and finally gets grinded into extremely fine powder, which are in nanoscale or are nano size. What are the advantages of ball milling, which is a top down approach? The capability to exactly switch the stoichiometry is there. The opportunity of creating multi component tools, capacity to create great clarity supplies, easy synthesis method at relatively low temperature. You don't really need temperature here. So basically, ball milling is a very common technique of creating nanoparticles using the top down approach. Physical vapor deposition. Here, this is a bottom up approach where we are using a vaporizing coating technique involving transfer of material on the atomic level under vacuum conditions. So you can see it in the diagram. Four major steps are involved in physical vapor deposition method for creating the nanoparticles. Here, the first method is called as Evaporation, first step you can say involved in the process is evaporation, then transportation, reaction, and then deposition. So it's a vacuum tube inside which the material is put, and then a component on the other side. First the material is heated, and then it evaporates, then transportation takes place, reaction will take place, and final deposition will take place. So it's a vaporizing coating technique. Types of physical vapor deposition are there are few types. The first is evaporative deposition, which is an electrically resistive heating. Second is sputtering, which is a glow plasma discharge. Electron beam physical vapor deposition, which contains electron beam bombardment. And the last is cathodic arc deposition, striking the coating material surface with high current. What are the advantages of physical vapor deposition? The advantage is that here the material to be synthesized in the form of nanoscale is being deposited due to the process of evaporation here on the substrate. So the advantages are uniform thin deposition of coating material. You can see over here we have the material which is to be synthesized in the nano form. The bulk of this material is kept over here. This is a vacuum chamber, and inside the vacuum chamber you increase the you due to the evaporation technique. By using the evaporation technique, the vapors of this material will be deposited on the substrate. So the reaction takes place and there will be deposition. The disadvantage is we require very high temperatures to create evaporation, and it's a vacuum based operation. So maintaining creating vacuum is very difficult. This operation cannot be performed on every substrate. The substrate on which the uh, deposition of the nanoscale thin coating is done, this substrate, you cannot use all the materials for this particular substrate, because the substrate is also going to react with the film being coated on it. There is reaction, therefore you cannot basically use all the materials, any material for the substrate over here. But on the other hand, physical vapor deposition, which is a bottom up approach, will be giving you an uniform and thin deposition of the material in the nanoscale in the form of a coating on the substrate. It's a very environmental friendly technique. Another bottom up approach is a sol gel method, and its advantages is significant chemical synthesis. Uh, Here, the precursor is first dissolved into a liquid, creating a sol, and then the sol is given heat treatment to create what we call as gel. So, sol gel method is a very simple method in which the mono-sized nanoparticles can be synthesized. Sol gel method is of two types, namely colloidal and polymeric or alkoxide sol gel method. The difference between the two is use of starting materials, what precursors you are using. Both the types involve suspension or dissolving of precursor into suitable liquid. So first the precursors are dissolved into the suitable liquid to form a sol, and then sol is dehydrated, reaction is takes place. It means you are going to give some heat treatment, and that gives you gel. So rapid drying of the gel will give you either aerogel, or some other process you can carry out suspension to give you zero gel. So after calcination, you will get a dense ceramic material which will be in the nano scale. So basically, it's again a bottom-up approach wherein you can very easily and chemically create nano-sized materials. So in the sol gel method, a chemical solution consisting of substrate dissolved into liquid solvent. It can be either water, distilled water, or alcohol, and uniformly separated up to molecular level. A desired coating material is dissolved in the sol, and a reaction is initiated using a catalyst. The catalyst can be either acid, hydrochloric acid base, or potassium hydroxide. Then a precipitate formed after heating away the solvent, which is partly solid and partly liquid, consisting of precursors. The precipitate is a uniform mixture of initial components. What are the advantages and disadvantages of sol gel method? Advantages are there's no need for high temperatures and vacuum. It is easy to obtain because materials of desired shape can be obtained through chemical method. High quality material with low cost and maintenance. Some disadvantages are that some residue of solvent may remain in the precipitate and thus making it little impure. This we've already seen. Now we will classify the nanomaterials based on their dimensions. Um, the first classification is zero dimensions. Sorry, which is the examples are spheres and clusters. One dimension, where at least one dimension of your nanoscale material is in the nanoscale. Nanofibers, wires, and rods are one dimension. Two dimension are films, plates, and networks, and three dimension are the nanomaterials. So here are some of the examples of three nano dimensions, two nano dimensions, and one nano dimension. So three nano dimensions are nanoparticles, which have nanoscale ranging from 1 to 100 nanometers, nanopowders, nanocapsules, fullerenes. The structure is shown in the diagram. Dendrimers, quantum dots, nanostructures, nanopores, all are three dimension. Nano dimensions in you do directions, that is nano dimensions will be nanofibers, nanowires, nanotubes. You can see a nanotube in the figure. One nano dimension means a nano thin film. So what are carbon nanotubes? These are very important materials as far as the applications are concerned. So nano tubes are carbon allotropes, or you can say allotropes of carbon with a cylindrical nanostructure. Because of that, they are termed as nanotubes. They have the length to diameter ratio of up to, as you can see, the ratio is already on the slide. So ratio is very unbalanced, you can say. So basically, nanotubes are the members of the fullerene structural family. Their name is derived from their long hollow structure with the walls formed by one atom thick sheets of carbon called graphene. Nanotubes, they find carbon nanotubes, which are nothing but allotropes of carbon. They find variety of applications, and from that point of view, they are very important. What are the properties of carbon nanotubes which are synthesized? They have highest strength to weight ratio. It helps in creating lightweight spacecrafts, aircrafts. They are lightweight because of the highest strength to weight ratio of the nanotubes. They can easily penetrate membranes such as cell walls, helps in the cancer treatment. Electrical resistance changes significantly when other molecules attach themselves to carbon atoms. This helps in developing sensors that can detect chemical vapors. So, carbon nanotubes have properties which can be helpful in various applications. As we can see, because of their highest strength, they can be used in lightweight spacecrafts. Easily, they can penetrate the membrane, such as cell walls, and then, therefore, can be used in cancer treatments. Electrical resistance also changes significantly when other molecules attach themselves to the carbon atoms here, so helps in developing sensors. Applications, as I told you, there are many. Some of them are listed here, with wherein commercially also carbon nanotubes have been used. Eastern Belt Sportsing uses CNT in making bicycle components, and this is already being in use. It is already being used in the companies and industries. So some of these examples I have quoted over here. uh, Zyvex Technologies, it's a corporation which uses CNT, that is carbon nanotubes, for manufacturing of lightweight boards, replacing transistors from the silicon chips, as they are small and emits less heat. They can be used in electric cables and wires, in solar cells, and in fabrics as well. Now, what are nano rods? These are the quantum dots. Nano rods are one morphology of nanoscale objects. Dimension ranges from again 1 to 100 nanometers. They may be synthesized from metals or semiconducting materials. What are the uses of these nanorods? Basically, in display technologies, because the reflectivity of the rods can be changed by changing their orientation with an applied electric field. In microelectrochemical systems, in cancer treatments, nanobots. These nanobots are close to the scale of 10 to the power minus 9. Largely, they used in the research and development phase as of now. And nanobots of 1.5 nanometers across, capable of counting specific molecules in a chemical sample. Since nanobots would be microscopic in size, it would be probably be necessary for very large number of them to work together to perform microscopic and macroscopic tasks. capable of replication using environmental resources. What are the applications? They are used in drug delivery, biomedical instrumentation, detection of toxic components in the environment. So nanobots can be created. They can be of very small size and usually 1.5 nanometer scale, and they can be used for various applications like drug delivery, for biomedical instrumentation. So nanobots again have various applications. Um, Factors affecting the physical properties due to the nanoscale dimension. First is large surface to volume ratio, as I already told you. They have large surface area. Second is changes due to quantum effect. So, how properties of nanomaterials are different from the bulk materials we have already discussed. But two major things which affect the behavior of the nanoparticles compared to the bulk materials are the surface area and the quantum confinement effect. So, very small particles have large surface area compared to the same amount of material in the larger lump. When a bulk material is reduced to the particle of smaller size, then the surface to volume ratio becomes very high. As the surface of the particle is involved in the chemical reactions, larger surface area can make the material more reactive. Grains of salt, they dissolve in water more quickly than a rock of salt. We all know that. So in fact, some materials, they have generally inactive, and their larger form can be more reactive in the nanoscale. Hence, at nanoscale, physical properties such as friction and sticking become more pronounced than they are in the normal system. So larger surface area, because the size is small, and hence larger surface area, it adds to many more applications because of the properties being different. So materials become more reactive, friction and sticking becomes more pronounced, and therefore they behave differently than the bulk materials. Another important property that they show is the quantum confinement effect. It is very well known that an isolated atom will have discrete energy levels. We all know that every atom will have discrete energy levels, even E2, E3, E4, so on, which are allowed. Naturally, some solids have split energy levels known as energy bands. We've studied this in the semiconductor, or you can say band theory of solids. But nanomaterials have an intermediate stage. As far as the physics at the nano level is concerned, it is in the quantum effect that deals with the properties. At reduced dimensions, they are said to have either a quantum well, a quantum dot, or a quantum wire. Actually, when the size of the grain is reduced to the nano level, then overlapping of the wave function and the quantum confinement occurs. If we consider d, small d, is the diameter of the nano level, or the grain size, then the energy goes up by the factor 1 by d square. So you can say that energy is directly proportional to 1 by d square if d is the diameter of the grain size. So if the diameter is reduced, then the energy obviously is directly proportional to 1 by d square. So when the dimension of the potential well, or the box concerned with the particles, is reduced to the order of the de Broglie wavelength, this we have studied in the quantum mechanics already, within few tens of the nanometer, then the energy levels of the electrons obviously change. And this effect is called as quantum confinement. And because of this, the properties will change in the magnetic domain, in the electrical domain, in the optical domain. And therefore, we can say that nanomaterials basically have very different properties than the bulk materials because of two major reasons. First is surface area, second is quantum confinement. They have very large surface to volume ratios, and because of what we call as quantum confinement effect, they will have nanomaterials will have an intermediate stage, and you can say that the energy here is directly proportional to 1 by d square, where d is nothing but the uh, grain size diameter, and hence obviously the energy changes because the dimensions are changing here, and this will affect the properties which are in the optical range or in the electrical and magnetic field, as we've already seen. So let us see some of these special nanomaterials. We will see two. One is graphene, the other is zeolite. Graphene, what is graphene now? It is an allotrope of carbon consisting of planar sheets which are one atom thick, with atoms arranged in the honeycomb or shaped lattice. So you can see over here in the diagram, the structure is like a honeycomb of graphene. So graphene is a two-dimensional single atomic planar sheet of sp2 bonded carbon atoms. that are very densely packaged into a honeycomb like structure. So the lattice is like a honeycomb, and it is essentially made up of single two-dimensional single atomic planar sheet of one atom, which consists of carbon atoms, and it is essentially a very large polyaromatic hydrocarbon, as you can see in the figure. Graphene is flat monolayer of carbon atoms which are tightly packed in a two-dimensional honeycomb lattice, and is basically a building block of the graphitic materials of all dimensions. What are the unique properties of graphene? Why it is special? Because graphene has high electrical conductivity. Its conductivity remains stable over a vast range of temperatures. So even if you go on changing the temperatures, the conductivity will be stable. It has fastest electron mobilities. Potential applications of graphene. Why graphene is an important nanomaterial? Because it can be used in various fields. It can be used in energy storage, gas sensors, transistors, conductive plates of ultra capacitors, electrode materials, biocatalytic devices, transmission electrons microscopy, which we call as TEM, uh, desalination, conductive plates, and you name it. There are various applications in solar cells also. So graphene basically is nothing but a honeycomb like lattice, which is made up of sp2 bonded carbon atoms. It's a two-dimensional planar sheet which is made up by one atom, and basically it has very high conductivity, stable conductivity at various temperatures, and very fast electron mobility. So it's a very important material as far as the applications are concerned. These are some of the diagrams wherein you can see the structure lattice of graphene. The figure A shows one layer, then figure B shows few layers of graphene. Then we have graphite finally, graphene oxide. You can see in diagram number E, wherein we have added some new few atoms here, and then reduced graphene oxide as a different structure, a little modification in the parent graphene structure, you can say. Another special nanomaterial is zeolite. Now, what are zeolites? Zeolites are, you can see in the diagram, microporous aluminosilicate minerals, which are commonly used as commercial adsorbents and catalysts. So, basically, zeolites, they are important because of their catalytic uses, and they can be basically used as commercial adsorbents also. So, these are nothing but very microporous aluminosilicate minerals. Zeolites, they occur naturally, but they are also produced industrially for various applications, obviously, on a very large scale. Diagram is shown on the figure slide. Production of zeolite industrially, important zeolites are produced synthetically also, but they are naturally occurring as well. Typical procedures entail heating aqueous solutions of alumina and silica with sodium aluminate and sodium silicate. What are the properties of zeolites? Why are they important again? Zeolites have a porous structure, as I have shown you in the figure. They can accommodate a wide variety of cations such as sodium, potassium, calcium, magnesium. These positive ions are rather loosely held and can readily be exchanged for others in contact solution. So they have very porous structure, and these cations, wide variety of cations are present. Naturally occurring zeolites are rarely pure and are contaminated to varying degrees by other minerals, metals, quartz, and other zeolites. What are the applications of zeolites? I have already told you they can be used in catalysts and can be used for, as we have seen here, they can be used as commercial adsorbents. The applications are listed here. They have unique porous properties. Zeolites are used in variety of applications, in water purification, in water softening, to separate the molecules of separate certain sizes and shapes, to remove the carbon dioxide, then H2O from low grade natural gas streams, for removal of fission products from the nuclear waste, for long term storage of energy at a density 4 times more than water, as a solar thermal collectors, and for absorption refrigeration. Various applications are there, as it can also be used as a water moderators, in which they can absorb up to 55% of their weight in water and slowly release it under the plant's demand. This property can prevent root rot and moderate drought cycles, and effective ammonia filter. They're used for water softening, water treatments. Nuclear effluents containing radioactive isotopes can also be cleaned up to certain extent using such zeolites. There are various solar thermal collectors which are using zeolites for absorption refrigeration. So you can find many applications in many fields for zeolites and graphene, which are these two very important nanomaterials that we have to study. Uses of zeolites we have already seen, but let's see a few more. Zeolites based oxygen concentrator systems are widely used to produce medical grade oxygen. Zeolites can be as solar thermal collectors for adsorption refrigeration, used as catalyst, adsorbents. They can widely be used as ion exchange beds in domestic and commercial water purification, softening, and other applications. Now we've seen how nanomaterials are produced. We've seen what are nanomaterials. We've seen what is nanotechnology, what is nanoscience, how they are different, and how they are synthesized and prepared by bottom up and top down approaches. Then we've also seen how bulk materials are different than the nanoscale materials, and also how these properties, unique properties, can be of use. And we've seen two very special nanomaterials like graphene and zeolite. Now we will see what impact nanomaterials have on the society. There are certain benefits, there are certain pros, there are certain cons. So let's see first of all what are the benefits that nanomaterials provide to the society. The following are the benefits of the society where we use the nanomaterials. Nanomaterials can be environment friendly, provide universal clean water supplies. They can be used for water treatments. Automatically engineered foods and crops can be produced, resulting in greater agricultural productivity. You can use it in agriculture and increase the productivity with very few labor requirements. It can produce very cheap and powerful energy, and therefore can be used in energy generation. It can provide clean and highly efficient manufacturing of machines. What are the potential risks? As I said, if there are pros, there are cons. So we've seen what are the benefits. There are certain cons as well. When we use nanomaterials without any balance, then obviously there will be health issues, there will be environment issues, there will be social issues, and there will be an effect called grey goo. So we'll see all four potential risks that nanomaterials pose. First is health issues. There can be various health issues if nanomaterials are put into the environment without check. Nanomaterials can have the same dimension as biological molecules, such as proteins. So, you never know if they are put in the environment without any check, then there can be health hazards. Studies specifically dealing with the toxicity of nanoparticles have only appeared recently, and we don't know much about it. So, these nanomaterials put in the environment can cause very high health problems. The toxicity of nanoparticles we don't know much about, but then it has appeared recently and people are concerned. The characteristics of nanomaterials that are relevant for health effect are size, chemical composition, and surface characteristics and shape. And we know that nanoparticles are so small where their dimension is comparable to the biological molecules such as proteins. So if they are taken in, they can cause health problems. Particulate matter present in the air pollution, especially from the traffic emission, is known as to affect human health, although it is not clear exactly how. Nanoparticles, either as drug itself or as the drug carrier, can also affect our health. Environmental issues. So the environmental impact of nanotechnology is possible effect that use of nanotechnological material and devices will have on the environment. Green nanotechnology refer to the use of nanotechnology to enhance the environmental sustainability of process producing negative externalities. It includes making green nano products and using nano product in support of sustainability. Nano pollution is a generic name or all waste generated by nano devices or during the nanomaterial manufacturing processes. So basically, it can affect the environment if we don't take a tab on the nano pollution and nano waste generated by the nano devices. and therefore we can refer to what we call as green nanotechnology, which includes green nano products and using nano products in the support of sustainability. So ultimate test is for a throwaway society, where how we are dealing with nano pollution, how we are getting rid of the nano waste, or you can say that the waste created by nano products. Effects of pollution, you can have nano particles in the air, in water, in the it can go into the respiratory systems and can cause you respiratory illnesses. Soil, they can contaminate the soil, they can contaminate our waters, they can go unchecked into our air, and hence can cause various health problems like headaches, fatigues. Okay, there can be skin irritations, they can be the cause of cancer, nausea. So all these are the problems associated with nano waste. Social issues, what are the social issues pertaining to nanoparticles? Beyond the toxicity risks to the human health and the environment, pollution, which are associated with the first generation nanoparticles, nanotechnology has a broader social impact, and it poses a broader social challenge also. So, social scientists have suggested that nanotechnology's social issues should be understood and assessed not as simply as downstream risks or impacts. Many social scientists and organizations in civic societies suggest that nanotechnology assessment and governance should also involve public participation. Now, you know that nanoparticles have various pros also. There are benefits, there are advantages, there are various applications. It can revolutionize almost every field, whether it's chemistry, physics, industries, society, everything. But then there are cons also. There are health risks involved if we put out the nano waste without proper consideration. If the nano waste goes undetected into our air, into our soils, into our water, and ultimately our bodies. So basically, toxicity risks, the environment pollutions created by the nano waste is one thing, and social issues is another. So basically, social impact of the nanotechnology requires broader understanding, and therefore the social scientists want people's participation in deciding the governance and assessment of nanotechnology. And then there is a fourth aspect called grey goo. Now, what is grey goo? Basically, grey goo is a hypothetical end of the world scenario involving molecular nanotechnology in which out of control, self replicating robots can consume all matter on Earth. It's a concern while building more of themselves, a scenario that has been called ecophagy, eating the environment. The original idea assumed machines were designed to have this capability, which popularizations have assumed that machines might somehow gain this capability by accident. So there is a concern when it comes to possible risks, or you can say probable risks involved in nanotechnology. A hypothetical concept called grey goo. Now, grey goo means it's a hypothetically end of the world scenario where it is being concern of there is a concern of the uh, nanobots or the self-replicating robots using nanotechnology to go out of control and start taking control of the whole system, and then eating the environment. So basically, it's a hypothetical end of the world scenario involving consummation of the matter on the earth by the self-replicating robots. So that's a probable risk that nanotechnology can pose as far as the cons are concerned. Now, we'll come to the major concept of applications of nanotechnology. What can nanotechnology do for us in spite of its risks? Now, nanotechnology has a potential to increase the efficiency of energy consumption, help clean the environment, solve major health problems. But then they can also create health problems if they go unchecked into our environment. But when it comes to applications, yes, we cannot deny that nanotechnology and the use of nanotechnology can have various impacts on our health, on our energy consumptions, on cleaning our environment. It is said to be able to massively increase manufacturing production at significantly reduced costs. It can produce very small, fast, cheap, light, yet more functional nano devices. They will require less energy, fewer raw materials to manufacture, and they can be used for various applications. In short terms, or in simple way, we can say that we'll be working smarter and not harder while producing products that will be of beneficial use to everyone. So these are some of the I've listed. There are many applications of nanotechnology, and the list is very, very long. So I have chosen a few, and I'm showing you a few applications in varied fields of nanotechnology, starting with sunscreens and cosmetics. So nano-sized titanium dioxide and zinc oxides are being currently used in some sunscreens as they absorb and reflect UV rays. Nano-sized iron oxide is present in some lipsticks as a pigment. Fuel cells, now this is another varied field in which they are used. The potential use of nano engineered materials to intensify catalytic processes could enable higher efficiency small scale fuel cells. In the display devices, where CNTs are being investigated for low voltage field emission displays, nanocrystalline zinc selenide, zinc sulfide, cadmium sulfide, lead telluride are candidates for next generation light emitting phosphors. They can be used for magnetic applications. And it has been shown that magnets made of nanocrystalline uh, yttrium samarium cobalt grains possess unusual magnetic properties due to the extremely large grain interface area, and this could lead to applications in motors, analytical instruments like MRI machines used widely in hospitals, and microsensors. They can be more functional, they can be made more functional because of the unique magnetic properties. Nanoscale fabricated magnetic materials have application in data storages. Devices such as computer hard disk storage capacity is very high in the case of nanomaterials in magnetic nano field. They can be used in batteries. With the growth in the portable electronic equipments, there is a great demand for lightweight, high energy density batteries, and nanotechnology can help. Nickel metal hybrid batteries made of nanocrystalline nickel and metal hydrides are envisioned to require less frequent recharging and to last longer because of their large grain boundary area. Nanocrystalline materials are candidates for separator plates in batteries because of their foam like aerogel structure, which can hold considerably more energy than conventional ones. Now, nanotechnology can also be used in catalysts because of their more reactive properties due to their larger surface to area ratios. Nanoparticles are very high catalytic properties, are very reactive, and they have high catalytic activity. They can be used in medicine for various diagnostics and uh, for various cures, for drug delivery. There's something called nanomedicine. Nanobots can be used for drug delivery. Unfortunately, in some cases, the biomedical metal alloys may wear out within the lifetime of patients, but nanomaterials increases the lifetime of the implant materials. So you can use them for implants. Nanocrystalline zirconium oxide zirconia is hard wear resistant, biocorrosion resistant, and biocompatible. It therefore presents an attractive alternative materials for implants. So, nanomedicine, then nano implants. Nanocrystalline silicon carbide is a candidate material for artificial heart valves, primarily because of its low weight, high strength, and inertness. So, basically, high mechanical strength, high reactivity, then having more bio corrosion resistance, biocompatibility. Nanoparticles, therefore, can be great materials for implantations, for medical uh, treatments, for diagnostic purposes, and for um, drug delivery. So, water purification is another area in which we can very well use the nanomaterials. Nano engineered membranes could potentially lead to more energy efficient water purification processes. So, this is used in water treatments as well. How can military and defense be untouched by nanotechnology? Military battle suits, which are now using nanomaterials, enhanced nanomaterials, form the basis of state to the art battle suits that is being developed. A short term development is likely to be energy absorbing materials that will withstand blast waves in case of a war. Long term are those that incorporate sensors to detect or respond to chemical or biological weapons. For example, responsive nanopores that close upon detection of a biological agent. They can be used in magnetic nanomaterial applications. It has been seen, this we've seen already, I think. Um, Now, last we come to how and where is nanotechnology being used or studied in India. The list contains certain organizations where nanotechnology is being studied and being applied and uh, created, basically. So, IIT Mumbai is a premium organization in the field of nanotechnology. They are working on nanotechnology in India on the large scale. Uh, Production of nano devices, studying the properties and research and development on the nanomaterials is going on extensively in IIT Mumbai. Then there is research in the field of health, environment, medicine, which is still on in India. Starting in 2001, the government of India launched the Nanoscience and Technology Initiative, which is called as NSTI. Then in 2007, the Nanoscience and Technology Mission was initiated with an allocation of rupees 1000 crores for a period of 5 years. The main objective of Nano Mission are basic research promotion on nanotechnology, infrastructural development for carrying out front ranking research, development of nanotechnologies and their applications, human resource development and international collaborators for collaborations for nanotechnology. So with this, I would like to end my presentation. Now, I would like to give you a 5 minutes break for question answers. If you have any queries, you can ask. Otherwise, I will be posting a Google form um, on the chat box. You can take the small quiz of 20 questions on nanotechnology. These questions are the basic questions which we have today discussed. It is based on the presentation of today. So, whatever we have seen in today in the presentation, in the seminar, the questions based, 20 questions based on all these slides. I would like you to take a small quiz on that. So, I'm posting the link on the chat box. Please take the quiz. It takes nearly 5 minutes to take the quiz and submit. Thank you so much. I hope you can see the quiz. Am I audible?
Hello. Hello. Thank you very much, madam. Uh, Hello.
Thank you, sir.
Thank you very much, madam, for your nice presentation on nanoscience and nanotechnology. We all are benefited through this live webinar. It is very useful for all our budding engineers. Okay, thank you very much, madam. Madam, you can share your link in this uh, quiz link in this group. Okay, we'll also share in WhatsApp group to the student also.
Sir, it's already shared. I hope you can see it.
Okay, you are shared now. Okay, madam. Okay, madam. Okay,
Okay, if
okay, madam.
anybody has any
Okay, madam.
queries, you
Thank you.
can put it on the chat box or comments. We'd be
Yes.
happy to answer.
Uh, if students have any queries, then they can put their queries in the chat box. Uh, I think there isn't no queries from students.
Okay,
Okay,
sir.
madam.
Okay.
Okay, thank you very much again for
Thank
your
you, sir.
nice presentations.
Thank you,
Okay, madam.
everyone.
एंड करना है एंड करना है एंड करना है
ठीक है?